previous lectures, we did the detailing of reinforced concrete beam, reinforced concrete column, and isolated footing using Autodesk Revit. Now, in this lecture, we will be focusing on the reinforcement of the slab. First of all, we will model the slab in Autodesk Revit, and then we will place the reinforcement after importing the rebar shapes into Revit. Let's draw the structural slab. Now we have drawn the structural slab. We can also modify the properties of the slab by clicking on it. Let's save the model first. The structural slab is drawn between the two reinforced concrete beams. Now let's edit the properties of the slab. We can also change the thickness of the slab to our requirement. Let's cut a section through the slab. Let's hide the levels for clearer visibility. So I have already imported the rebar shapes as discussed in the previous lectures of how to import the rebar shapes into Revit using Revit libraries. You can visit the channel and look for Autodesk Revit playlist to see the lecture in detail. We have to select the appropriate bar. Now I am specifying the cover manually for the slab using a detail line as a reference, and I'll move the rebar on the detail line and then delete the detail line as it's just for the reference. Let's turn on the bar visibility in the 3D view so that the bar is visible as solid in 3D. Now our bar is visible in 3D view as 3D extruded form, that is a solid form. Let's cut a longitudinal section so that we can duplicate the bar along the slab dimensions. So there is our bar placed. Let's first move the bar to the corner of the slab and then we'll create copies of the bar. Let's move at a distance equal to the cover. Let's say I am taking 1 inches cover, so I have moved it 1 inch from the edge of the slab. Now I'll copy the bar, or you can either change change the edit the group of the bar by changing the quantities of the bar. Let's say I am specifying 100 bars and a spacing of, let's say, 6 inch or 5 inch. So now the bars are specified. Let's change the number of the bars so that the bars, you can also calculate this number manually, but right now I'm just entering the arbitrary numbers so that the bars fit into the span of the slab. Now the bottom reinforcement of the slab is added in the slab. In a similar manner, you can add the top reinforcement of the slab. We have to be careful when placing the bar. That the bar do not intersect each other and appear realistic as they will be executed on the site construction. Using the rules of ACI code, the bar should be extended, or you can say the extra bar should be extended. Extra top bar shall be extended to a span length of L by 3, where L is the length of the span we have to divide the span into 3 parts, and the top bar shall come one part on the left and one part on the right. So the span length was divided by 3, and the bar was extended on the first third, and the last third will be copying it. So I am moving the bar to the cover distance. Now I'll be doing the mirror command on the bar so that it comes on the left as well. Similarly, I have deleted the detail lines which I placed for the reference of the bars only. So for clearer visibility of the top bars, I have turned off the visibility of the bottom bars. Now I'll be creating the set of top bars. You can also copy or create copies of the top bars, but it is better to create the set of the bars by specifying number of bars, so that when you select a bar at top, then all the top bars will be selected in an instant. So I have turned on the visibility in 3D view. Now I am changing the bar numbers, that is, I am creating the set of bars. Now similar to the bottom bar, I am copying or moving the top bar at a distance to the corner of the slab. Cover was already specified for the bottom bar, so I am just copying it using a detail line. Now I'll be moving my bars for the right side as well in a similar manner I did for the left side. First let's delete them and do the mirror simply, as we have done this for the right side already. So now we have assigned the top bars of the slab as well. And hiding the bottom bars. If you see, the top bars are still appearing as the line, so we have to select all of them and go to their visibility properties. Click on visibility states and select all 3D options and click on check or view as solid. So now they are visible as solid bars. or the extruded bars. That is how we draw the reinforcement of the slab in Autodesk Revit. In previous lectures, we have discussed how to check or specify or adjust the joints of the beam column slab. If your bars are not coming as solid, then you can select all of the bars and edit their visibility as we did previously. Right now I am turning off the visibility of the concrete elements and just giving you an idea of the reinforcement skeleton. So this is how a reinforcement skeleton looks like. Also we can turn off the visibility of the beams. So that is how our reinforcement skeleton will look like in Revit. To change the visibility altogether, you can go to edit visibility and make them view as solid altogether. Now you can save the model and then turn on the visibility of the concrete footing, column, beams and slab.